Hey, welcome back everyone, and welcome to our penultimate session. So we have Harsha with us again today for his second session of the day. And as you'll all be aware, we'll be covering the IoT connector. So that's enough of me. Over to Harsha, the stage is yours. Thank you.
Okay, thanks, James. Welcome back, everyone. In this session, we will cover the IoT connector, and we'll walk through all the different wonderful things that we have to offer in IoT connector. All right, just setting agenda in terms of what we will try to cover in this session. Again, I'll walk through the features and highlights of the IoT connector. What are the various things on offer? We'll also look at the system overview, which is basically to see what different components are part of the IoT connector and what each of them does. And we'll also look at the deployment modes, in terms of the pure cloud deployment, online deployment, offline deployment, or rather the on-prem deployment and the hybrid deployment modes. We'll talk about the operating modes that are supported by the IoT connector. We'll also talk about how you can control GPIOs and LEDs using the IoT connector. And the other thing that I'm personally very excited about is the DA apps. So we are introducing a new feature with IoT connector called the data analytics applications, which will allow the users to perform all sorts of different filtering and other analytics that they want to perform on the reader using the IoT connector. So this brings the analytics capability to the edge, and that's what I want to walk over with the DA app framework over here. And then finally, we'll run through a quick demo. I'll show how to set up the IoT connector, different endpoints, start tag reads, stop tag reads, and how you can view the tag reads, and so on. Okay, starting off, for features and highlights, IoT connector is supported on the following readers. So we support it on the FX7500, FX9600, and ATR 7000. So what IoT connector does is it provides a very easy to use cloud-friendly interface to the readers. And typically when you're working with a reader, if you're using either the RM or LLRP, in both these cases, what happens is that the application that wants to control and manage the readers would need to make a connection to the reader, which is obviously a sort of a drawback if you want to manage the readers from the cloud, because most of the readers, when they are deployed behind the corporate firewalls, do not allow external entities to go in and connect to the readers. So what IoT connector does is it flips that paradigm. Instead of the applications connecting to the reader is the one that initiates the connections and is sending out data. And that makes the readers very cloud friendly and provides it a lot of IoT capabilities that you can leverage. So in terms of IoT Connect capabilities, there are IoT Connector provides 4 different interfaces through which you can talk to the reader. One is called the management interface, there's the control interface, there's the data interface, and then there's the monitoring interface. Typically, I like to think of it as synchronous and asynchronous interfaces. Synchronous being when you send a command and get back a response. So your management and control are your synchronous interfaces, where you get back a response only on a certain command being sent. Whereas the data and monitoring interfaces are asynchronous interfaces, and these are initiated by the reader. So the data coming out of the reader, or the management coming out of the reader, management events coming out of the reader, are all initiated by the reader without the user having to send a command to the reader. So those are asynchronous interfaces. The other feature that is part of the IoT connector is the data retention. So I think we talked about a little bit in the previous session how LLRP buffers data in case of it not being consumed by the user fast enough. What IoT connector provides is similar, but instead of the consumption, what IoT connector does is, if it is not able to send the data events to the endpoint that is configured for data, it will start buffering it on the reader itself, and it will retain that data until the network connection is restored. And once the network connection is restored, it will send all the data back, so you don't lose any data. In addition to it, you can also configure the throttle at which the data is sent back. So if the network is down for a long time, for example, and if the reader is continuously reading tags, there is a possibility that it starts accumulating a lot of tags on the reader, and when the network connection is restored, it will just pump everything. So in order to avoid that, that has a potential to bring down the cloud service, which is managing all these different readers depending on how many readers there are, right? So in order to avoid that, what the feature in the IoT connector does is it provides the ability to throttle. So you can specify once the network connection is restored, at what rate do we want these events to be sent back to the cloud, so that it doesn't bring down the cloud application. So that is configurable as well. That's one of the features that in the IoT connector. And then, yeah, obviously it supports the radio operating modes. Operating modes is similar to here what the operating mode sort of replaces what you would do with an LLRP in the conventional case, where you configure the way in which you want the reader to read tags or do any sort of pre-filters, post-filters, yeah, or if you want to configure a GPI trigger for the reads, for example. So operating mode sort of encompasses all the functionality that LLRP provides into a simple configurable JSON object that can be sent to the reader. And you can easily specify or configure how you want the reader to behave, how you want it to filter, how you want the triggers to be handled, what tag metadata you want it to report, all that sort of thing. So there are, again, predefined operating modes. There are 4 predefined operating modes. We'll run through them in the slides further. But those 4 operating modes are, they do provide some customization knobs that you could adjust based on the use case. But then those operating modes provide, or rather will inhibit you from using certain knobs depending on which operating mode you are, because of the nature of the definition of the modes. But if you don't want those predefined modes, if you want full flexibility, Reader provides something called a custom mode, which is very expert level configuration, where all the knobs that are available to the user to adjust, and that can be used to achieve any functionality that you would otherwise have the reader do by LLRP. And then in terms of deployment modes, we support, the reader supports fully cloud deployment, where you are completely managing the reader, controlling the reader, and consuming the tag coming out of the reader from cloud. And there is an on-prem deployment where if the readers are located in a network environment where connection to an internet is not possible, then it can do a fully on-prem deployment. There are also hybrid operation modes where you could manage and control the reader from the cloud, but consume tag data locally to avoid expenses that are incurred with high network bandwidth utilization. So that's we'll run through those as well. The reader supports 2 simultaneous data paths. So in terms of the data paths that are supported, we support HTTP post, MQTT, and we support keyboard emulation, and a bunch of cloud providers as well. We support GCP, AWS, IBM, and Azure. So the 2 data paths, the simultaneous data paths that are supported, can be sent to any of the supported endpoints. So you could have the various combinations there. I'll demo that later as well. And yeah, I think, like I said, we are introducing the DA app framework here. What this allows you to do, one of the things that at least the DA app will allow you to do, is if you want to consume data and send it to 2 separate endpoints, but you don't want all the data to be sent to both the endpoints. You want different data to be sent to different endpoints. That can be done from the DA application. So typically what would happen is, if you don't want all the data to go to the cloud, if you're sensitive to the network bandwidth utilization, so you could filter out the data that goes to the cloud. But if there is a local connection that the data endpoint is added to as well, then reader can send the unfiltered data to a local endpoint, whereas the filtered data can go to the cloud. So that sort of a paradigm is possible using the DA app as well. And yeah, the framework is available in 2 language bindings. We support Python and Node.js, so users can write any applications using either of these languages and deploy on the reader, and that will be started in the, I mean, basically it will perform all the filtering operations that you would want on the reader. All right. A quick system overview. So these are the different components that are part of the IoT connector. So there is a reader gateway or a cloud agent. The other component is called the reader control, and the third component is the reader manager. So these are the 3 main components that are responsible for implementing IoT connector within the reader. The reader gateway is the one that is responsible for interfacing to the outside world. So any connections that it makes for management, control, and data are all held by the reader gateway. And that is the one that translates the IoT connector commands that are coming in on those interfaces to the respective components. So if there are management functionalities that are being asked of the reader to be performed, then the reader gateway would receive those commands and translate it into an RM command, which is internally sending to the reader manager, the RM server. And similarly, if there are reader or radio operation control commands, like the changing the operating mode or starting the tag reads or stopping the tag reads, those commands are translated and it's sent over to the radio control. So the reader gateway acts sort of like a switch and a translation logic, but it also provides other functionalities that we talked about, like the tag retention and the batching and so on. Radio control is the one that's responsible for interfacing with the radio. This is the one that is reading the tags, performing the filters, determining what tag metadata to send based on the user configuration. The operating modes that have been configured are also directly sent to the radio control. So radio control is basically the one that is replacing LLRP, if you will, in the conventional sense. And that's the reason when IoT connector is running, LLRP would be stopped internally by the reader, so LLRP functionalities would not be available because radio control then takes over the responsibilities or functionalities of LLRP. And then there is the reader manager. This is the RM server that you might already be familiar with, which provides the reader management capabilities that are exposed by the reader today. Then there is the reader web server. This is nothing but an HTTP server, an Apache server that is hosted inside the reader. This comes into picture when you're using the local REST. What local REST really does is it provides an ability or exposes certain REST endpoints to directly interact with the IoT connector by talking or connecting directly to the reader. So you can send HTTP requests to the reader directly and perform or exercise all the IoT connector functionalities directly from the reader if you don't want to go via an MQTT broker or any other cloud provider. So coming to deployment modes, so I earlier mentioned about the different interfaces we have. There is a management interface, there's a control interface, there is a data interface, and the monitoring interface. Now, depending on how you configure it, there are a bunch of deployment modes that are possible. So in this case, this is a pure cloud deployment. You can see that the black arrow indicates management and control, and the red arrow indicates data. In this case, what would happen is that the reader would connect its management and control interfaces as well as data interfaces to a cloud service provider. We support out of the box the GCP IoT Core, AWS IoT Core, the Azure IoT Hub, and the IBM Watson IoT Hub. So any customer application that wants to manage the reader in this scenario would need to interface with the cloud service provider. So if you are using, say, for example, the GCP IoT Core, the reader is actually connecting to the MQTT broker hosted by the GCP IoT Core. And if the customer application wants to then manage that reader, then it needs to interface with the GCP IoT Core and send the data using the PubSub service of the GCP IoT Core, and then, or rather, send commands using the GCP IoT Core, and then receive the responses back. And any data that is sent by the reader is also sent directly to the IoT Core, which the application can receive using the PubSub service. So that's the pure cloud deployment, and obviously this would require that the reader has the connection to the internet. The second scenario based on where the reader is deployed is called a local deployment. So in cases where the readers do not have internet access, which I presume is in most cases when it comes to corporate deployments, it is possible to have the management and control interfaces locally controlled directly by the application using the local REST that I just mentioned. And also the data can be consumed locally as well. So the customer application in this case would issue REST API request directly to the reader, since HTTP REST is always a request response kind of scenario that takes care of the management and control. And as far as data and management events are concerned, those can be configured to be sent over to another server. Either way, that can be either be an HTTP post server or just an HTTP server and use the post method to send the data over, or it can be an MQTT broker, in which case the customer application would need to subscribe to the appropriate topics on the MQTT broker as well to receive the data from the reader. We do support when there is a local deployment, there's a third data endpoint also possible, which is called the keyboard emulation. So in this case, what would happen is the reader, instead of sending the data over to an MQTT broker or an HTTP server using TCP/IP, if you connect the reader to a USB host of, say, a laptop or any other computer, then the reader will act like a keyboard, and it'll start sending data as keystrokes into the connected host. So if there is a spreadsheet or a notepad that's open, then you can start seeing all the tag data coming over into those applications that are running in the foreground. So that's the keyboard emulation mode. One quick thing I want to mention here is that if you were familiar with FX Connect as an application or a feature on the reader, that sort of supported all these different modes: the HTTP mode, the HTTP post, the keyboard emulation, and sort of thing. So IoT Connector is now bringing into its umbrella all the functionalities that FX Connect supported. So FX Connect, I think, is going out of life, which will be replaced by the IoT Connector. And that's where the keyboard emulation has come into the IoT Connector as well from the FX Connect world. All right, and then there's the hybrid deployment. So this is a case where if there are, say, for example, if on-prem is too complicated, if you don't want to have maybe if there are multiple sites, for example, and if there are readers deployed in each of the site, you don't want to have a separate on-prem server managing the readers on that particular premises, but you want to have a centralized management server, but then you want something to consume the data locally. So that sort of a scenario is possible in the hybrid deployment mode, where the management and control are connected to a cloud provider, be it a GCP, AWS, or IBM, or Azure. And the customer application can control these readers from the cloud providers, but then data can be consumed directly or sent over to any other local interface. That can be HTTP post or keyboard emulation or MQTT broker. So in this case, if the additional network bandwidth utilization that would have occurred if the reader was sending the data to the cloud is all avoided, because the data is now going local. And also in terms of the MQTT broker, right? So if there is a on-prem MQTT broker to which the reader is configured to send data, there are two different protocols through which we can send data over to MQTT. There is a TCP protocol, which which is the regular MQTT protocol, and there's the MQTT over WebSockets. So that's also supported in the IoT Connector. MQTT over WebSockets is usually preferred by some corporate IT departments, because that provides the ability to send data over ports 80, and if it is MQTT over secure WebSockets, you can send data over port 443, which is the standard HTTPS port, and that is usually favored by most IT departments, because then they don't have to open up additional ports. Like in case of MQTT TCP, they would need to open up the default port for MQTT TCP, which is port 1883. And even if it is, we also support a secure MQTT over TCP, which is MQTT TLS. But that again would requires that the port 8883 is open, because that is the default port for the MQTT over TLS. But if you're using a WebSocket or a secure WebSocket, MQTT over WebSocket or a secure WebSocket, then you can work with ports 80 or 443, which doesn't require, which in most cases are open in most corporate networks. All right, so that's the hybrid deployment. The other deployment scenario that is also possible is the dual data path deployment, where, like I said, we support two simultaneous data endpoints. The reader can now be managed and controlled from the cloud, but then you could have the data going out to the cloud as well as to a local server. The local server can again be HTTP, MQTT, or keyboard. And in case of, by default, if you add two different endpoints, with all the data that is sent over to one endpoint is also sent over to another endpoint. So in the absence of a DA application or the data analytics application, if you configure two separate data endpoints, both of them are going to be receiving the same data. They'll see the same data basically. And that's what is illustrated here as well. Okay. Moving on. So yeah, I mentioned about the different interfaces. There is a management, monitoring, and control. The data interface will be just a pure tag data going over the data interface. But in terms of management, monitoring, and control, what are the different things that are supported by IoT Connector? So if you look at the management functionalities, you can perform operations like getting the information about the reader. That includes the status of the reader, the network configuration, and the region configuration of the reader. And when I talk about status, you can get all sorts of information like the you can get the CPU utilization, memory utilization, disk utilization. You can get the NTP status. You can get the antenna connection, disconnection status. So all that is possible to be retrieved by the status API. Network will obviously tell you whether you're in a static IP configuration or an network IP configuration or a dynamic IP configuration, and it will also give you the current IP address of the reader. The region will tell what region the reader is configured to, and so on. And then the configure, in addition to getting the information, you can configure the reader as well. In terms of what can be configured on the reader, you can send a XML profile to the reader. This is similar to what you get in the profiles page of the Reader Web Console today. So the entire reader configuration can be exported as a single XML file and then can be imported back. The same XML content you can copy and paste into the set config command, which provides the ability to configure the reader using that XML. You can also configure the endpoints from the IoT connector itself. So once, I mean, for the first time you want to connect the IoT connector to some endpoint, you would need to enter that from the web console. But once it is connected, if you want to change the endpoint configuration, if you say, for example, don't want the data to be sent to the endpoint that it is currently sending to, if you want to change that, that you can change from the IoT connector as well. You can change the way the events are configured. Basically, events are sent out by default. These are, and when I say events, I'm talking about the management events here. These events are sent out once every 60 seconds by default. But if you don't want that behavior, if you want to change the interval at which the management events are sent out, you could reduce the interval. But also you can customize what events you're interested in. So if you're, say for example, you really don't care about CPU or memory utilization, then you can tell the reader, don't send me that information. Just send me the antenna connection, disconnection status that it'll send. So yeah, that sort of a customization can be done for how you want to receive the management events. Using the IoT connector interfaces, you can also configure the GPIO LED module. So this is, with the introduction of IoT connector, what is now also possible is that you can IoT Connector provides a rules-based management or control of GPIOs and LEDs. So you can set up events, or rather you can configure what events you are interested in, and how, depending on what events are triggered, how you want to control the GPIO and LEDs. And Reader will autonomously, once it receives that configuration, it will autonomously control the GPIOs and LEDs according to your configuration without having for you to actively control that from the application. I'll also demo this in a little bit. And then, yeah, using the management functionalities, you can manage the user apps. So you should be able to install user apps, start and stop the user apps, uninstall them, that sort of a thing. And you will be able to update the firmware as well using the management functionality. What is available in terms of control? You can set the operating mode of the reader. That is how the reader will read tags and how it will report tags and how often it will report tags. You can also start and stop the tag reads on the reader. So if you don't want to listen from this reader anymore, you can simply ask the reader to stop, and it will stop reporting tags. And also you can, yeah, that's on the control interface. On the monitoring interface, and like I said, this is an asynchronous interface, and these two are synchronous interfaces where you need to send a command to get back a response. So on the asynchronous monitoring interface, what you would get from the reader are the following events. So there is a heartbeat event. Like I said, it's sent out once every 60 seconds, and you can change that behavior if you want, but that's the default. There are GPI events. So if there is GPI transition that has occurred on any of the GPIs of the reader, that will be sent out as an event on the monitoring interface as well, so that if there is an application that is interested in knowing this event, that it can process that message on the MQTT or HTTP post server. And yeah, there are errors and warning events as well. So these typically what would happen is, in case of say for example, when you want to install a certain user app on the reader, the mechanism that is supported for today for user app installation is that the user app, when you send a command to the reader to install a user app, the user app itself must be hosted on a HTTPS server, and the reader will pull the user app and then install it. But in case there is something going wrong with the user app installation, for example, you will get back an error event on the management channel indicating that this failed or something went wrong here. Similarly, warning events are also available, and firmware update progress events are also sent out on the monitoring interface. So once you issue a firmware updates start command, the reader will send back a success response saying that it is initiating a firmware update, but then the progress itself is reported back using the firmware update. And if it fails in between, the error or warning events are sent on the monitoring interface. So this is what is supported in IoT Connector today in terms of the management control and monitoring. All right. Now, in terms of the operating modes or reader configuration, this IoT Connector simplifies how the or how you configure the reader operating modes quite a bit. So I think one thing that we are introduced in the latest release is also the ability to configure the deployment environment. So typically, when there are three different environments possible. There is a low interference environment, there's a high interference environment, and there's a very high interference environment. Typically, low interference environment is when you know for sure that there is not going to be much of an interference. Say, for example, you have only one RFID reader and there's no other readers nearby, and there are no other sources of RF interference near the reader. In that case, you can configure the environment variable to the low interference, and you would the reader will automatically configure itself based on the region. It will configure the link profiles and everything automatically, and you wouldn't have to configure that explicitly by yourself. There is a high interference environment where and this would be the typical case where if the reader is going to operate along with other readers, which is most likely the case, then it is recommended that you configure this to a high interference environment. This is also the default on the reader, so if you don't configure anything, it will automatically default to the high interference environment. And uh, and then there's the very high interference environment. The very high interference environment it's supposed to be picked when the readers are very densely packed together. So if there are more readers than there are available channels, then typically you should select a very high interference environment. The read rates obviously would depend on what environment you're configuring. So a low interference would probably give you a higher read rate compared to a high interference or a very high interference, and so on. And then, so this environment configuration is also possible to be made via the operating mode. So that you can configure the environment configuration as part of the operating mode configuration. And like I said, the operating mode itself, there are 4 default out-of-the-box operating modes supported, and there is one custom mode, which is an expert level or advanced level operating mode. The 4 operating modes supported are simple, inventory, conveyor, and portal. These are targeted towards various different kinds of use cases. In case of a simple mode, it'll start reading tags, and it'll read forever, and it'll report only unique tags. That's the simple mode. There are some customizations or knobs available for you to change the behavior. Say, for example, you don't want all unique tags, you want to filter out some things, you can do that. And if you can select the antennas on which you want to perform operations. So if you have more antennas and you don't want to read on all antennas, you can select the antennas on which you want to read tags. That's all possible using the simple mode. Same thing with the inventory mode. In case of inventory mode, in addition to the reader reading tags, it will report back. It'll do a periodic interval as a periodic inventory, if you will. So basically, it'll cycle through all the antennas, and whenever it reads tags, all the unique tags are reported, and then you can configure a reporting interval. And even though the unique tag was reported back then, it will report it again after that interval has expired. So that's what inventory mode does. And in addition to just the reporting parameter, you could also select filtering, antenna powers, or which antenna you want to perform the inventory on. All that configuration is possible using the inventory mode as well. And you get additional tag metadata in case of inventory mode as well. So say, for example, you read tags, and you get if the reader reports one unique tag, and if the reporting interval is set to say 1 second, the same unique tag is reported back after 1 second. But then it also reports the number of reads or the number of times that tag was read between the last report and the next successive report. So that sort of functionality is available on the inventory mode. Then there's the conveyor mode. Conveyor mode reads tags on all antennas by default, and it reports tags per antenna basis. And again, you can apply any sort of filtering that you want. You can select the antennas on which you want to perform inventory. The same configurations that are available in the simple and inventory is also available in the conveyor mode. In the portal mode, you could basically trigger tag reads based on a GPI trigger. So you can pick the GPI that you want to trigger tag reads on, and whenever the GPI goes to the configured state, the reader will start reading tags and start reporting unique tags. And by default, it'll keep reading tags until no more unique tags are read, and if after that, it'll wait for 3 seconds and stop reading tags. But if you don't want that, if you want to change that behavior, if you want to stop maybe 500 milliseconds after, or rather 1 second after the GPI is triggered, you can configure that, and the reader will basically read for 1 second after the GPI is triggered and report all unique tags. That's the portal mode. And custom is basically, it'll throw open all the doors for you. You can pick and choose any configuration, twist all the knobs. That's completely up to the user. That's an expert level configuration. I will also show in terms of documentation what are the different knobs available. I'll do that later once we run through this presentation. So yeah, once you know what operating mode to pick, you can configure that operating mode in one of two different ways. One is you can do that from the reader web console itself. There is a new web page that is added to configure the operating mode on the reader, or you could do that from the IoT connector interface. And that is basically if the IoT connector control interface is set to MQTT, for example, you can change the operating mode using the MQTT interface itself. So like I said, the IoT connector provides a rules-based mechanism through which you can control your GPIOs and LEDs. In order to do that, and again, I'll run through this in the video in some time, rather the demo in some time. But what this allows the user to do is the user can select the default state of all the GPIOs and LEDs, whether they want all the GPIOs to be low or high, or if the LED one should be off or it should be glowing a particular color. You can select all those defaults. And once you've selected the defaults, you need to basically pick the event of interest. And there are a few predefined events that are available. So you can pick the event of interest, and whenever that event is triggered, there are conditions that you can specify. And if those conditions are met, the actions that you configure will be performed by the reader automatically. See, for example, and what one of the scenarios could be that whenever the GPI1 is triggered, and if the radio is reading tags, if I want to turn the LED red or green, or if I want to turn the GPO to some state, I could do that automatically. So once that configuration is set and saved on the reader, it'll keep monitoring for those events, and it'll keep performing those actions as long as IoT connector is running. So yeah, this I'll show you how to configure that from the reader web page as well. Okay, so that brings us to the user application, the DA app framework. So basically, the idea here is that the DA apps are going to be user-written applications that can be written either in Python or Node.js and can be deployed on the readers. Once the applications are deployed on the readers, you can see that this introduces a new component in the way the IoT connector functions. So instead of the reader gateway directly consuming data from the radio control and sending it out, now the flow of the data will change. The radio control will now start reading tags and send data to the analytics script first, and let the analytics script do its whatever business logic is embedded in that script. And then the analytics script can send the data over to the radio control, or rather, sorry, the reader gateway, and the reader gateway will send it out. So all the analytics script in this case need to worry about is how you want to handle your data. If you want to reformat your data, you can do that. It doesn't need to worry about how to send the data out to any other endpoint. It doesn't need to worry about it doesn't need to worry about things like what happens if the data connection is lost, because the reader gateway is then going to batch and retain that data and send it over when the connection is restored. So all the goodies of the reader gateway that are otherwise available are still available when the analytics script is running. And the analytics script is solely responsible for processing the data the way you want to. That's one thing that analytics script can do. Now, the other application or other use case that the analytics script can satisfy is also real-time control. So in many cases, what would happen is you would want to typically control the GPOs on the reader based on certain events. So say, for example, if you read a particular tag that you were interested in, and if the idea is to control the GPO whenever that tag is read, all that business logic can be embedded within the analytics script. And because of the nature of the analytics script, and because it is running on the reader itself, it can directly control the GPO in real time. And the GPO event now doesn't I mean, the GPIO doesn't have to be controlled by an external application. It can be done on the reader itself. And also, I think, like I mentioned in previous slides as well, the analytics script can be used to send different data to different endpoints. So we support two different endpoints, data endpoints on the reader. If the idea is to send all data to one endpoint and only some filtered data to a second endpoint, the analytics script will come into the picture here, and it can filter out all the data that it doesn't want to send to the second endpoint and send only that data that it's interested in to the second endpoint. So that is possible as well. And also it can reformat the data. So the data that is coming out of the radio control is coming in, say, the JSON format. Say you're not interested in receiving JSON format data. Say you want key value pairs instead of JSON format. And that probably comes in handy when you're doing say keyboard emulation, for example. There's a spreadsheet and you want to directly insert data such that it is listed in different columns automatically. So you can format your data accordingly and send it out. The data gateway will promptly send it out to the keyboard emulation endpoint or any other endpoint that you might have configured. So all that can be done by the analytics script. So the analytics script in itself, first of all, needs to make use of what is called the DA library. Again, there are two different language bindings that are provided. There's a Python module and a Node.js module that is on board on the reader itself, which the analytics script needs to import. And once it has imported those modules, there are APIs available for both Python and Node.js, using which the analytics script can do its thing. It can receive the data from the radio control. It can send the data to the reader gateway. It can control the GPIO. Everything that's possible from the analytics script can be done using the library. Yeah, what the library also does is it completely abstracts the underlying connection, so the analytics script doesn't need to worry about how do I connect to radio control, how do I connect to reader gateway. Like in the previous slide, we were talking about, it places itself between these two. The script itself doesn't need to worry about it. Once it has included the DA library, once the Python or the JavaScript has imported the appropriate module, the module internally is taking care of establishing those connections to the appropriate components, and the user script as such doesn't need to worry about it. So once the DA library is written either in Python or Node.js, and it has imported the DA library, and it knows how to transform the data, all the logic is written, the analytics script must be packaged and installed on the reader. This will be very similar to how the other embedded user apps will be installed. So it needs to be packaged in a Debian format, similar to other embedded applications. And you can install the application itself, again, using two different methods. One is from the reader web console. There's an applications page. You can go and browse for that application and install it. Or you can install the application itself from the IoT connector management interface. So you can host the application somewhere and send a command to the reader to download and install it, and the reader will do that. Okay, so this is the library interface. There are a few different, I just want to illustrate here what is minimally required by the user applications to do. The first thing that will be required is to create this GIOTC object. So, and this is, I'm taking a Python as an example here. So what would be required is, once the script has imported this GIOTC module, it needs to instantiate or initialize the library using the GIOTC call. And then once it has done that, it needs to register itself to get a message callback or get a callback whenever a data event from the radio control is received. And the library will take care of calling the callback whenever it gets a message from the radio control. Then there is the run forever. So the Python module makes use of what we call the async IO module, or rather what is popularly known as async IO module. And this is an asynchronous loop. So the entire application is run as a async IO event loop. So you need to start the loop once you've registered your callbacks. The user application is then supposed to start the loop by calling the run forever. This will cause the callbacks to be called by the DA library whenever there's a message from the radio control. And there's the other function called the send next message. What this will do is basically in your callback, whenever the Python or rather whenever the message callback is called by the DA library, the library itself can then process the data as it needs, and then once it is ready to send the data out, it can simply call send next message and specify the type of message it is sending and what is the message that needs to be sent out. Once that is done, the reader gateway will take care of sending the message appropriately. So these are, at a very minimal, these are the 4 API calls that need to be made in order to write a DA application. I'll just walk through a full-blown script and show you how simple it is. Now, the other thing I talked about when we said we want to control the GPI or GPOs as well, that can be done by using the send next message. You see here, there is one argument called message type. There are 3 different message types that are available. One is called a data message, then the other one is called a control message, and then the third one is called a GPO message. Now, data message is simple. Whenever the DA application gets a callback from the radio control or gets a data event from the radio control, you process the data appropriately, and then when you want to send it back, you just send it back and set the type to data. And the reader gateway will then know that this is a data message from the DA app, and it needs to be sent to the data endpoint. And the reader gateway will take care of it. The second type of message that is possible is the control message. Now, this message, okay, so in some cases, it might be useful for the DA app itself to send out, say, heartbeats, for example, if you want to monitor the state of the DA app. And the application on the other side, be it in the cloud or on-prem, can monitor the state of the DA app and take actions appropriately. Not just the monitoring, but also if there are any additional management events that need to be sent out to the external application, that can be also sent out using the control type message. When the reader gateway sees that the control type message has been sent from the DA app, it will send it to the management interface instead of sending it to the data interface. So the application that is managing the reader will actually get that message from the DA app. And then the third type is the GPO event message type. When you send the GPO message type, it'll directly result in a GPO being controlled on the reader itself. This type of message is not sent out from the reader. So those are the 3 message types. So this is a very simple, small sample DA app written in Python. As you can see, there are basically at a high level, what this application is doing is it is filtering the tags based on a prefix. So if the tags start with the numbers 4 and 3, then it will send it out. If it doesn't, then it will just drop the tag. That's what this application is doing. So in order to do that, there is a new message callback, which is implemented by the user application. Here, I think what it is simply doing is checking the type of message that it has received. In this case, it is the tag info, and it's in the JSON format. That's the enumeration for the message type that is being sent to this module or the callback. And then it is parsing that information, and it is getting the tag ID of that in that event, and checking if it starts with this prefix. If it is starting with that prefix, then it will send the message out to the reader gateway by setting the message type to data. If it is not starting with a prefix, it will simply drop it. That's what this is doing. Now you might have noticed there's a second callback here. This is called the pass-through callback. Now what this will do is it may be required for the DA apps, or in some cases, it may be the use case may be that the client or some management application which is managing the readers, they want to send a command to the DA app instead of sending it to the reader itself. Now, if you want to send the command to the DA app, then there is a separate IoT connector command called the set data to user app. that can be used by the applications. And once the DA app registers a pass-through callback, that command, when received by the reader gateway, will send it directly to the DA app, and this callback will be invoked. So in this case, what this pass-through callback is doing is it is simply changing the prefix. So in this case, it's a dynamic filter. So if by default, this application will keep filtering on prefix 43, but at some point you decide you want to change the filtering prefix. You don't want to filter by 43, but maybe by 86. You could simply change the prefix without having to rewrite the application by sending a command using the pass-through callback. And the command actually will be sent to the reader gateway. The reader gateway will then send it to the DA app, and when it sends to the DA app, it will automatically issue a callback to this method where it is then changing the prefix. That's what this is doing. All right, so that's all I had in terms of the slides that I wanted to run over. I just quickly want to share the documentation and where you would, or what we have coming in terms of documentation. And what I would do is, instead of looking at the current online documentation, I want to run quickly over through what you can expect to see in the near future. And this is the documentation format that we are looking at as well. So this is the most of the sections that you see here is already there in the online form documentation, but we are documentation with some additional sections as well. So you can see that the regular sections about the system overview, that's all there. The deployment modes are explained here as well. And then there's the operating modes that are explained here. So you can see what each of these does in terms of tag reports and all so on. And then there is the how do you start tag reads, basically. So that's what this section is. It's a quick start guide. You can configure some endpoints and start tag reads. And then there is the how-to guides. These guides specifically walk you through how to connect to ZDS, for example, AWS, GCP, IBM, Azure, MQTT, HTTP post, if you want to do that. There's also a section on how to change the GPIO and LED configuration using the reader web page, which I'll just walk through in a little bit. And yeah, there's a separate section on the user apps. This is where you can expect to see the explanation of different user apps. There's a Python programmer's guide, which will walk you through how to write a simple user application. We are still working on the Node.js, but that will be there as well. And there's a package and deployment, which will tell you how to package the application, how to deploy it on the readers, and so on. We've added some sections on certificate management, and we are also coming up with some migration guides. Like I said, the FX Connect is going to be end of life. And if there are customers out there who are using FX Connect and they want to migrate over to IT Connector, this section would help figure out how to go about that migration in terms of what you had from FX Connect and porting it over to IT Connector. And then these are all sections that you had before as well. So yeah, that's what I wanted to share in terms of the documentation. Okay, maybe I just want to quickly show a quick demo as well. So in the new reader interface, if you go to the communication Zebra IT Connector, these are the 4 new pages that we've added. There's a configuration page where this will allow you to add different endpoints and configure different endpoints. You can map the endpoints to the different interfaces as well. If you go to the add endpoint, these are the currently supported endpoint types on the reader. You can see if I go back to configuration page, I've already added 2 endpoints here. There's one MQTT and then HTTP post server. I can go ahead and if I want to add AWS or HTTP, IBM or any other endpoint, I can do that as well. So just for demo, I'll just quickly walk through how to configure an MQTT endpoint. So in this case, what would happen is you need to specify a MQTT broker server address. The name is mandatory, so you can specify something like MQTT 10. And then followed by, you can specify the server IP, or in this case, if you want to use the publicly available EMQX broker, you can do that by typing emqx.broker.io. The port number that you want to select, this is 1883 by default for the EMQX public broker. And like I was mentioning earlier, there are these different protocols that are supported with the MQTT broker as well. So there is a TCP protocol, which is over port 1883 without any security. There's an MQTT over TLS, in which case this would be port 8883. This would enable encrypted and authenticated message communication between the MQTT broker as well as the reader. Then in addition to that, there's a WebSocket and a secure WebSocket as well that you can configure on the reader. So I'll maybe select TCP here, 1883. So once you've added that, you need to specify a client ID. Typically, the client ID can be anything you want, but in most cases, I just provide test. And then once the connection parameters are configured, you can go and configure the topics that need to be that the reader should subscribe to and that you can expect the reader to send data to. Like I said in earlier, there are two asynchronous interfaces and two synchronous interfaces. The asynchronous are management and tag data events, and there is only one topic, and the reader sends data to this topic. So in this case, the reader will be the publisher, and any application that is interested in those events will be the subscriber. But in case of synchronous interfaces like the management and control interface, there's a command topic and a response topic. You need to configure the command topic, and the reader will subscribe to this topic, and the application that is interested in managing the readers will need to publish to that topic. And there's a response topic through which the reader will send back the response. So reader will be the publisher in this case, and the application that is managing the readers will need to be a subscriber. And the same is true for the control interface as well. So if you want to quickly do like you can configure topics. Maybe I'll skip this portion in the interest of time. I'll go over to this. I'll show you what I've added here in my endpoint that I've already added. This is the connection that I've set up, and these are the topics that I've configured. There's a monitoring, data, command and response for management, and then there's a command and response for the control. And once I've added this topic, it'll show up in the table over here. I can similarly add a HTTP post topic by going over to this, select the HTTP post, set the URL, and there are a bunch of different authentication modes that are supported by the reader. You can select any one of those. In my case, it's none. And if you are using HTTPS, you can select certificates as well. So that's already added on my reader. So I'll just walk through that quickly. And what I've done here is, if you like, you can see there's a management interface which I have configured to the EMQX broker. There's a control interface which I've again configured to the EMQX broker. And there's a tag data interface. There are two tag data interfaces, 1 and 2. And you can configure them to either the EMQX or the HTTP post. Now you can see that the HTTP post is only visible in the asynchronous interfaces because that's not supported for synchronous interfaces. So that you can select one as HTTP post, which is a webhook, and the other one to an MQTT. So the reader will send data to both of these endpoints simultaneously. And the management events are sent over to the EMQX broker. In addition to that, I have also checked here the local rest management and control. What this will provide me is an ability to control the reader locally, but also control the reader using the MQTT broker. So I can send using Postman an HTTP request to the reader to get, say, the version of the reader, for example. And I can also do it from the MQTT broker. So there is dual management interface, if you will, and dual control interface, and also dual data interface. So once all of that is done, you click on it and update and come to the connection page and click on connect. It'll connect to all these endpoints. In my case, the reader is already connected to all of these. I can quickly demonstrate how to use a local rest for management and control. In order to do that, first the user must log into the reader. The reader will return a Java Web Token. So if I send, for example, I get back a new token, which I need to use in the further request as a bearer token authentication method. But in order to get this token itself, I need to use a basic authentication and use the admin and username and password that is used for my reader web console. The same username and password must be specified. So once I get back a token, so if I want to do get a status, for example, because of the set of the environment variables such that it automatically substitutes the token over here, and the authentication is bearer token, I send a request, I get back the reader status. So you can see the antenna status, the flash CPU, flash, all different sorts of statuses here. I can also start and stop tag reads. So say, for example, if I want to start tag reads, now the reader is reading tags. I have subscribed this MQTT client to the MQTT broker that I've configured. I also want to show here the webhook site. So you can see that now the reader is sending data to two different endpoints. One is coming over to the webhook site as a HTTP post. The other one coming over to the MQTT broker via the MQTT broker. Then I can issue a stop and it'll stop reading tags. That's basically how you can start and stop tag reads on the reader and see the tag data. I think the couple of other pages that I want to quickly walk through was the operating mode. This is the one where you can change the operating mode of the reader. You can select one of the 4 different modes that we talked about, the simple, conveyor, inventory, and portal. In case of the inventory and portal, there are additional options available, which are called mode-specific settings. You could select, in case of portal, what GPI trigger you want and what state it should be in for it to start reading tags, and the stop interval, how long you want the reader to read tags after the interval or after the trigger has occurred. The same thing with inventory. You can configure the duration at which the inventory will keep reporting tags back to the data endpoint. Custom mode, you can configure. In this case, this is, since all the knobs are available, this is completely a text box that you can simply type a JSON object into and click save, and it'll save that on the reader. In terms of environment configuration, I talked about the 3 different environment configurations. They're very low interference, high interference, and very high interference. These are available here from the operating mode web page. You can specify the tag ID filter. You can, if you're looking for tags with a certain pattern, you can select that. There is a prefix, suffix, and a regex kind of a match available. So if it's a prefix, it'll report all those tags that start with a prefix. If it's a suffix, it'll report only those tags that end with a suffix. And if it's a regex, it will do a tag pattern matching and report only those tags. And you also can select whether you want to report those tags or drop those tags. Include and exclude operation will either report those tags or drop the tags. There's a report filter duration as well that you can select, which tells how frequently the unique tags are reported back to the data endpoint. And you can change the select the antennas that you want to perform the operation on and their transfer power. So that's the operating mode. Quickly, I want to cover the GPIO configuration here. The GPIO LED configuration, this is the page where you can select or configure how you want the GPIO LED module to work. In this case, once you select the defaults of each of these individual GPIOs and LEDs, what would the user need to do is select the event of interest. So by default, these are the events that are supported. So if you're interested in a GPI event, for example, you can select GPI. I'm interested in GPI2, and I want to know whenever the GPI2 is pulled low. And if the GPI2 is pulled low, and if you want to take some action, but base it on a condition, say, for example, you want to do it only when the cloud is connected. So if the GPI2 is low, and if the cloud is connected, and if you want to control the GPIO1 to high, for example, you can do that. So once you click on add, it will show up here in the below table, which will indicate what the added configuration was. So you can add multiple such configurations and keep adding, and then click on save, which will eventually be saved on the reader. In terms of the conditions, you can select more than one condition. So if I go back to this one here, so we said GPI1, and we want to take action only when cloud is connected. But I also want to check radio ongoing status. And I can select an operator. Either I want both these conditions to be met or one of them to be met. You can select the operand here and then select the operation that you want to perform, whether it's a GPIO control or an LED control. And the reader will autonomously take actions based on what is configured over here. All right, so I think that sort of completes what I wanted to cover on the IoT connector. Not sure if we have sufficient time to take questions, but James, back to you.
Thank you very much, Harsha. That was a great presentation, very thorough, much appreciated. So as you'll probably realize, we have overrun the session slightly, so we're just eating into the break, but we have plenty of questions. So we're going to spend 6 or 7 minutes or so getting through as many of these questions as we can, And then, as we've done for previous sessions, we'll put together a Q&A document afterwards with any questions that we didn't get to. So let's get started and get through as many as we can. So first question, Harsha. I have used IoT connector, but I didn't find a way to activate antenna 1 and 2 with GPIO 1 and antenna 3 and 4 with GPIO 2. Is it possible?
Well, unfortunately, that's not supported yet. So I think you basically, if I'm not wrong, you're asking about an operating mode configuration, something like a portal, where you want to have multiple GPI triggers. And based on that GPI trigger, you want to select which antennas the operation will be, tags will be read on. And if that is correct, if my understanding of your question is correct, unfortunately, that's not supported. The portal mode only takes one GPI for now. There has been an ask in terms of how we can support multiple GPIs as triggers, but that's probably sometime in the future.
Okay, thank you. Is there compatibility with Microsoft Azure IoT platform, i.e., are we planning to be Microsoft Azure IoT certified?
Yeah, I think in the configuration page, if you go to the add endpoint, that's one of the endpoints that we support as well, the Azure IoT Hub. So you can specify the hub name, the port that you want to use. I think Azure only always supports 8883, which is the secure MQTT protocol, the device name and debug, and then you can also configure the topics. So that's already supported on the IoT connector.
Excellent, thank you. How many reads can IoT connector buffer? Is that 60,000?
Well, it's slightly higher on the IoT connector, but when it comes to IoT connector, the reads are different when compared to LLRP. Like I said earlier, in case of LLRP, each tag read is buffered, or every tag report is buffered. Or reported back. But in case when we talk about IoT connector, what we really talk about is not a tag read, but rather a data event. And a data event itself can be generated after multiple tag reads, right? So for example, when I say, if I'm operating in simple mode, for example, simple mode will continue to run forever and it will keep only reporting unique tags. And since that's the only data event that goes out, no matter how many tags that is read, how many times that unique tag is read, not every single tag read is reported back. It only reports the unit tag once. Now, because that is the only data event that's going out, and because the IoT connector can buffer up to 150,000 events, the number of tag reads over which that gets the buffering gets applied is really huge. And it all depends on how your operating mode is configured. And what mode you're on, what reporting interval you have set, for example. So depending on that, yeah, the default, maybe I can quickly show that here as well. So over web endpoint, there's a batching and retention tab here, where you can select how many tags you want to retain. As opposed to LLRP. So 150,000 is the max allowed, but you can configure it. Also, you can configure the throttle, the rate at which you want these retained tags to be sent back once the connection is restored. But like again said, the data events in case of IoT connector do not exactly correlate one-to-one with how LLRP buffers the tag reads. It's much more.
Okay, great, thank you. So is there a specific firmware version required to use IoT connector on the FX75 and 9600?
Yeah, that is correct. So I think the IoT connector was already available in the firmware version 3.10.30 that we have on the support site. Although not all of these pages were there, that was more a beta level functionality rather than a full official launch. The upcoming release that we are making, hopefully in a few days or week, would be a more official launch of the IoT connector, and the firmware version that you can expect to see is 3.21.20.
Perfect, thank you. The current 3.10.30 firmware has keyboard provisioning?
Oh, it doesn't. That is something that we've added that's going to be out in the next upcoming release.
Okay, perfect. What forms of authentication does IoT connector support for the readers, both over HTTP as well as MQTT? Specifically, is OAuth supported?
Well, OAuth is not supported, but for HTTP, we support other forms of authentication. The basic authentication is supported, only digest, NTLM, and NSAF are supported. There is a TLS, what we call the TLS authentication type. Basically, this is a certificate-based authentication where you could configure the reader to connect to the other endpoint only if there is a mutual authentication enabled. That is, if the reader knows about the CS certificates of the endpoint that it is talking to. So yeah, these are the ones that are supported. OAuth is not supported yet.
Okay, great, thank you. Given that Google Cloud IoT Core is being retired in August 2023, has Zebra started testing with Clearblade, which is pointed to as the replacement for Google Cloud IoT Core?
So yeah, I think we have been discussing internally on how to handle the retirement of the GCP IoT core. The talk is, I think they would want to move towards a gRPC based protocol. I think that's what we are looking to support as well, but there's no clear timelines as to when we would be ready to support that officially on the IoT connector.
Understood. Okay, we've probably got room for 2 or 3 more questions. So does the IoT connector have to be used? Will it be the only way to connect to readers in future? Can developers use the same methods they currently use to connect to readers?
So I think as far as the FX and ATR readers are concerned, IoT connector will be yet another interface on top of the currently available interfaces. So you would be able to use whatever mechanism that you are currently using to talk to the reader and continue to use it. But I think in the future readers, we might the direction that we are heading towards is to standardize IoT connector and move to an IoT connector only interface by default.
Okay. So with the FX9600 using IoT connector, how do you configure the time in which the reader can react to internet disconnection? At this period of reaction, usually 30 seconds, the readings are lost. Does that make sense?
Okay, so I think the question probably means how do we know when the data endpoint has disconnected and start the retention on the reader itself. So I think by default, the HTTP post endpoint, I forget the timeout on it, but 30 seconds is close to what we have. Maybe I can get back to with the exact timeout, but yeah, what would happen in case of readers is if there is a data event that needs to be sent out, the reader would try to send it to that data endpoint, whether it's MQTT or HTTP post. And if that attempt is unsuccessful, if it fails for some reason, then the reader will save it. And the reader also preserves the order, so the next time someone gets back, there is a data event received from the reader control, we would attempt to send the previous event first and then send the next event. And if they are successful, then retention doesn't come into picture. But if that fails, then we'll preserve the successive data events as well. So the exact timeout is around 30 seconds, but that's how we decide when to retain data and when not.
Okay, perfect. So with that, I think we're going to have to leave it there. We're going to have to move on to the next session. So apologies if we haven't got round to your question. As I've mentioned, we'll put together a document and send a link. So I'd just like to finish up by saying thank you very much, Harsha, for your second session. Another great presentation. Hopefully everyone enjoyed it and learned a little bit more about IoT Connector. I'm going to end this session now and move over to our final session of the day, which is around 123 RFID desktop. So we'll see you there in just a moment. Thanks again, Harsha.
Thank you. Thanks a lot. Bye.